Hey guys, I was noticing there's a good amount of confusion on these kind of problems to do with Hardy-Weinberg. So I kind of wanted to just go over one together. So the big thing to look at here first is which allele is dominant and which one is recessive. So I know I have two different alleles here, big B and little b. Now it says there's 100 squirrels and 50 of these are homozygous dominant, 30 are heterozygous, and 20 are homozygous recessive. What I'm going to do actually is I'm actually going to make these different colors just so it makes it a little easier to follow these things. Oops. Okay. So what I'll do first is I'm going to write out the different genotypes. So we have the first one is just homozygous recessive or homozygous dominant, and there's 50 of them. So homozygous dominant, right, is just big B, and I'll do the numbers in black. So there's 50 of them. There's 30 are heterozygous, meaning that we have one big B, one little b, and there's 30 of those. And then we have 20 that are homozygous recessive, so little b, and 20 of those. Okay. So the next step here is to figure out, okay, well, what's my number of each of these individual alleles, right? That's the part I need to do here. So we'll say we're going to do the number of B alleles to start off with. So what I'm going to do is I'm going to say, okay, well, I know that every animal, sorry, I don't know why this isn't going away. Screen. We know that every squirrel, so I'm going to say this circle is a squirrel. Every squirrel has to have at least two alleles, right? So I know that if 50 of them have two of these alleles, well, then my total number of big B's in each of these is 100 because there's two of these. So I have to multiply this by the two of them, which gets me 100 total. But I'm not done quite yet because I have one more big B here. And remember, there's 30 total of both of these letters. So I know that there's 30 big B's here because I'll just multiply it by one of the big B's. So this gives me 30. And this comes up here with these. So now my total here of these two is 130. Now I do the same thing for little b, right? Multiply by 2 because there's two of them. This gets me 40. There's one of these here, but since there's a total of 30 of these, I just do the same thing. So times 1 gets me 30. These two give me a total of 70. And the way you can kind of, oops, let me undo that because we're doing these in black. So the way we can check this is, well, that's going to give me a total of 200 alleles if I added both of these together. And so this makes sense because I have 100 squirrels, right? I have 100 total squirrels. And for each squirrel, I expect them to have two alleles. So I expect 200 total alleles. Okay. Now, how do I do the relative allele frequency? Well, to do the relative allele frequency, all I have to do is take my number here, right, my number of a particular allele, and divide it by the total. And so I do that for each of them. Which trait appears to have a higher fitness? Well, to do that, you just figure out which one appears the most in this case, or which one has the highest frequency. In this case, it is the dominant allele. So which trait, though? That would be bushy tails. Okay, And bushy tails, I could also write right there. I could write capital B. Okay, let's clear all that. Now, what do I do here? So now it gives me the same one. So I'm going to solve this out really quick, and then we'll look at this. Okay, so I've solved this one. This says that later on they did another study, and we measured those same squirrels, and you noticed that these are the new numbers that you recorded. So we found the allele frequencies here. It turns out now big B is 60 and little b is 140. And remember, you just divide both of these by 200. But before that, what we can do, oh no, dang it. Let's take a look at what our old frequencies were. So from our last problem, our big B was equal to 130, and our little b was equal to 70. So what this question down here, it says, what can we conclude based on these allele frequencies? Well, what you do is you're going to compare each of these two. How do they compare? Well, you'll notice, if you take a second to do that, that big B increased, or little b increased, and big B decreased. What does that mean? Well, that means that now it looks like that this trait is more fit for the environment because there's more, there's a higher frequency of it. What you can also say is that based on Hardy-Weinberg, because Hardy-Weinberg is talking about evolution, if the allele frequencies change over time, you can say this is what evolution really is. So you can say evolution is happening. And you can say evolution is happening because the allele frequencies are changing. Now, if we had an example where these allele frequencies did not change, so they stayed at the same number, then you would say evolution is not happening. So it's all about how these allele frequencies change over time. Okay, thanks guys, and I hope this answered or cleared that up.